In 0.5, we're looking at inverses algebraically. So our first step is you want to rewrite f of x as y. So I'm going to change this to y equals 2x minus 3. Our next step, you want to switch x and y. So now I'm going to rewrite this where instead of y equals, x equals, and instead of 2x, it's 2y minus 3. And then we solve for y. So I need to get rid of that 3 by adding 3 to both sides. X plus 3 equals 2y. Divide both sides by 2. So we get x can't be divided by 2 evenly, 3 can't be divided by 2 evenly, so I'm going to leave this as y equals x plus 3 over 2. Then our final step is just making sure you're using that inverse notation. So I'd make a note that this is our inverse notation. So whenever you see f of negative 1, f to the negative 1 power of x, that's our inverse notation. So I'm going to rewrite this as f to the negative 1 power of x equals x plus 3 over 2. And that's our final answer. So let's go ahead and look at this next example. Step 1, rewrite with y equals 2/3 x plus 1. And then step 2, switch x and y. So now I'll rewrite it as x equals 2/3 y plus 1. Solve for y. X minus, whoops. X minus 1 equals 2/3 y. Remember, to get rid of a fraction, we multiply by the reciprocal. And on that left side, we have to make sure that we put it in parentheses, so we distribute that 3/2. So I'm going to continue up here on the right. So we have 3/2 times x, which is 3/2 x. 3/2 times negative 1, which is negative 3/2, equals y. So now rewrite this in inverse notation. F to the negative 1 power of x equals 3/2 x minus 3/2. This could also be written, because those have the same denominator, with a single denominator. Same answers. Alright, I challenge you to pause the video and try this third example for yourself. So, rewrite y equals 3 minus 4x. Switch x and y, so we get x equals 3 minus 4y, and then solve for y. Subtract 3, x minus 3 equals negative 4y. Divide by negative 4 on both sides. So then we don't leave a negative in the denominator, so if I move that to the numerator, it then becomes negative x plus 3 over 4. So notice both those signs in the numerator switched, equals y. And then we rewrite this in inverse notation. F the inverse equals negative x plus 3 over 4. So those are some of our basic inverse examples. We might have sometimes some more complex equations like this. So this one already starts with y, so we'll start with step 2 and switch those. X equals y squared plus 1. Subtract 1 on both sides, so we get x minus 1 equals y squared. And then we want to get rid of a squared, so we have to square root both sides. So we get the square root of x minus 1 equals y. Which then we rewrite in our inverse notation, and it should be f to the negative 1 of x equals square root of x minus 1. Okay. Here's a similar example, but instead of having a square root, we have a, or instead of having a x squared, we have a square root. So rewrite with y. Switch x and y. X equals square root of y minus 4. And then solve for y. To get rid of a square root, we need to square both sides. So x squared equals y minus 4. Add 4 on both sides. X squared equals, x squared plus 4 equals y. And rewrite in our inverse notation. So the inverse is x squared plus